Now we can see about discrete time Fourier transform and this property. For discrete time Fourier transform, while after completing this, the students can apply the discrete time Fourier transform on discrete time signal for solving the engineering problems. Now, what is meant by discrete time Fourier transform? It is a transformation that maps discrete time signal x of n into a complex valued function of the real valued variable, namely f of x of n equal to x of e power j omega equal to summation n equal to minus infinity to infinity x of n into e power minus j omega n, and the inverse discrete Fourier transform is given as x of n equal to f inverse of x of e power j omega, and it can be given as 1 by 2 pi integral minus pi to pi x of e power j omega into e power j omega n into d omega, where n varies from minus infinity. Next problem, find the Dtft of x of n equal to a power modulus of n. Here a power modulus of n means it includes both the negative as well as the positive limit. Therefore, now we are going to apply the formula. We know that the formula is x of e power j omega equal to summation n equal to minus infinity to infinity a power modulus of n into u of n e power minus j omega n, which can be, we are splitting this into two limits, that is negative side and positive side, and also here the negative limit we are just changing the negative limit into positive. Therefore, while we are changing, the summation is also changes, therefore it varies from m equal to 1 to infinity, and this is n equal to 0 to infinity. Now we are applying the standard formula for this first summation and as well as the standard formula second summation. After taking the LCM and simplifying, we are getting the value as 1 minus a square divided by 1 minus e 2a into cos omega plus a square. Now we can see some of the properties here. Properties of Dtft. First one is the linearity property. It states that the discrete Fourier transform of x1 of n plus x2 of n equal to discrete Fourier transform of x1 of n plus discrete Fourier transform of x2 of n, which is nothing but x1 of e power j omega plus x2 of e power j omega. And second one is time shifting. If the discrete Fourier transform of x of n is x of e power j omega, then we want to prove that the discrete Fourier transform of x of n minus n naught equal to e power minus j omega n naught into x of e power j omega. Here we are going to apply the Fourier transform for the shifted property. Therefore, by applying this and by substituting the values, that is n minus n, for simplification we are substituting that n minus n naught equal to m. Therefore, all the values we are changing in terms of m, and finally after rearranging the equation and taking the constant term outside, we are getting this value as, that is e power minus j omega n summation of this value, which is equal to the given proof. Time reversal, that is, if Fourier transform of x of n equal to x of e power j omega, then we want to prove that x1, that is Fourier transform of x of minus n equal to x of e power j omega. Second one, convolution. The statement is the Fourier transform of x of n equal to x of e power j omega and the discrete Fourier transform of y of n equal to y of e power j omega. Then g of e power j omega equal to x of e power j omega into y of e power j omega. Now we can prove this. Therefore, we know the value for x of n, and that is x of n and y of n is nothing but we are applying the convolution formula. While applying the convolution formula and rearranging this equation, and here n minus m, for simplification we are just substituting the limit and rearranging the terms, we are getting the term as, that is first term into second term, which is equal to x of e power j omega into y of e power j omega. Next one is frequency shift. It can be, that is if discrete Fourier transform of x of n equal to x of e power j omega, then discrete Fourier transform of e power j omega naught n into x of n equal to x of e power j omega minus omega naught. And next one is multiplication property. If the discrete Fourier transform of x of n is x of e power j omega and the discrete Fourier transform of n into x of n equal to minus z into d of x of z by dz at z equal to e power j omega. And next one is Parseval's theorem. It states that the discrete Fourier transform of x of n equal to x of e power j omega and the discrete Fourier transform of y of n equal to y of e power j omega, then summation of x of n into y conjugate of n, which is equal to 1 by 2 pi integral of x of e power j omega into y conjugate of e power j omega into d omega. Here we know that the Parseval's relation is, this is the formula. Here we are applying, we are just taking, for simplification I am just taking the summation inside, and therefore this can be written as x, that is x of n into, we are rearranging this equation. Here we are just taking that x of n is y of n. By applying the formula we are getting the final solution. Next one is multiplication of sequence, that is the discrete Fourier transform of x of n is x of e power j omega and the discrete Fourier transform of y of n is y of e power j omega. Therefore, the discrete Fourier transform of x of n into y of n equal to x of n into y of n into e power minus j omega n. Here we are applying the formula, that is partial realization is applied for y of n formula, rearranging this equation, and finally we are getting this final value, hence proved. Next one is differentiation in the frequency domain, that is if the discrete Fourier transform of x of n is x of e power j omega, then d of x of e power j omega divided by d omega is given by d by d omega. We are just differentiating the term inside the bracket, and finally we are taking the minus j term outside. Therefore we are getting that this is the discrete Fourier transform of n into x of n. This question. Thank you.